Today we'll be looking at a couple of language features we've missed through the last couple of sessions. And the first one we're introducing is the so-called object initializer, which is just a handy little trick to set up specific classes a bit faster, or instances of a class. We need to create first, say with a class player, and the player has a name and a certain amount of gold and experience, whatever. And first option we have is of course to create a player like so with the default constructor and then just assign values like this. Gold equals 100 XP. Well, actually we can leave XP probably. No, let's be generous. 1000 experience, whatever that could mean in our context. Now, doing it this way is a bit annoying to write. Could be a bit faster maybe. Instead of writing this out hand by hand, piece by piece, we could use a constructor, of course. So public player, and then just have a string and gold and XP. So then name equals name, gold equals gold, and XP equals XP. XP is actually an interesting case study for naming conventions. Like, I want to write XP as uppercase completely, but if I use the naming convention I usually stick to, I would actually have to make this lowercase p. But that looks weird to me, so I stick with uppercase, but that sometimes happens. I'm getting distracted. Anyway, this is another way to do it, so instead of writing this out by hand, actually let me... No... Okay, I'm learning some new key combos apparently. That's not what I wanted though. Works. Just comment that out, and instead I put that in here. 100, 1000. And that would get us the same result. We would create a new player and give it a certain amount of gold and experience and have them have a name. But there's a third way, and that's the object initializer. So let's say I'm ignoring this constructor. Let's just comment that out here. That's the other way to do it. Let's use the default constructor for now. It's not that you can't use it with a constructor combination, we'll get to that in a second, but let's just use the default for now. Instead of ending the constructor call here, where we basically call the method of the constructor, which is just a special method, we can add curly brackets. Actually, let's put it on one line first. Like so, and we do stuff inside these curly brackets, and then we have the semicolon. So let's put that on a new line now, just to have a bit more overview. And what we can do is we access the variables of this player instance now. It's a bit like as if we write this code that's inside the constructor. Only we can't really call code directly. We can only access the fields and properties of the player, but otherwise we can do this. And the important bit is I'm using a comma in here, not a semicolon like I would do with normal code. I'm using a comma. So in that sense, it's a bit closer to arguments. And then gold equals 100 and XP equals 1000. And just to see if they're compiling. And but oh, I'm an idiot. Like that. So this works out. Now let's just confirm that it outputs the correct values. Console.write right, 9 line. player, 100, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, named plus p.name plus has plus p.gold gold and xp plus xp. Let's call that. And yeah, our player has named name, has 100 gold and 1000 XP. So this is the object initializer. We gave custom values for our fields in here using these curly brackets, and the whole thing counts as one instruction still. Only one semicolon here, this is one instruction, and then there's another instruction down here, and the second one and the third one, no matter how many you put in there. And at this point, I should probably demonstrate something. Let's change this field into a property. Actually, let's change this to... yeah, let's... private string, let's call name. Change things to a property that's accessing the purely hidden internal field name. And that's first we're implementing the get part of the property, which will just return name. And set is going to be a bit more special, because we can write code in here. Line. We're gonna add a simple output that tells us when someone changes the value of the name. We're gonna name was what's name and is set to plus value. Just in case you don't remember it, value is the keyword that we use inside the set part to reference a kind of a variable that we want to set the property to. Like if I set, or if I use name dot or name equals something, I would call this method, and the value I passed on with the equals sign here is what's getting put into value. So this is just a keyword that lets me access whatever I have put in here, for example, or in here. So with this, I'm getting the previous value and the value I'm setting it to, and then of course we set the value. Like so. And just to confirm, first output worked. And maybe we should make that a bit clearer. Some quotation marks around here, maybe in there as well. And, oh, forgot, set to. So it's easier to see where the actual name is, and that right now there is nothing in here. So the previous name was nothing and is set to something else. Actually, string might not be the best idea because you can see the difference between null and string. So let's change this. This is gonna look a bit weird, but name is null. We use a ternary operation. Name is null, then null. Else we output name plus, right. Okay, let's do it the classic way. Don't like this, but wait, equals null. Wrong way around, like that. Okay, so the very first time we instantiate the instance, so when we create the object, everything starts off with just zeros on the heap. Keep in mind, this is a class, so the entire object, everything we store in here is stored in the heap. And when the memory is reserved for the first time, it's gonna be filled with nothing but zeros, which is just the number 0, of course, for our integer. But string is an object. It's a reference type that's also sitting on the heap. So a value of 0 just means the address is 0, because as a reference type, this is just the address in the heap for our object. And address 0 is just invalid, just means there is no address, there is no object, which is the keyword null. So the very first time we set this value, which we right now do here, the name was still null, the address was still 0, there was no name from when the object was first put on the heap, and then we set it to our new value, which is name. Let's add the constructor back in. And do it like this. 2, 1, 2. The object initializer still works. As mentioned, it doesn't matter whether the constructor is the default constructor or something we did. We can use this. Just now you see two calls of this. The very first value is still null, because the object was initialized. The space was reserved on the heap with nothing but zeros. So the original first value is null. Then comes our constructor, which is the first method that's called, because it's meant to construct the object. We start with a basic template with just zeros, and the constructor is now supposed to form this reserved space on the heap with nothing but zeros into a valid object. And to do so, it will fill name with the actual address for a proper string somewhere else on the heap. And that is the string foo, which is somewhere on the heap. And then after the constructor is finished, let's call it after the constructor is finished, we use the object initializer part, which is not a new instruction, which is kind of part of the construction here, but it's happening after the constructor is finished. And so now when the object initializer assigns this string to name, it is already filled with the previous value foo, and we override it with name. Let's do something else. What if I do this, which I can do? What is the outcome now? What do you think? Well, I mean, maybe it was obvious, but what you don't see is this name was still 0 at one point. The thing is, we assigned a value pretty fast, and only after we assigned this value did the constructor start, and we used the property. And here I assigned the value directly to the field. Down here we use the property, and only when we use the property do we get this code to run. Could also try to do this. Of course, that doesn't quite work, unfortunately. Though you can use the equal sign for properties, it doesn't work in this context right now. So we have to live with the knowledge that we don't know what's happening. I'm just telling you. Name still starts out with a 0 in the heap the very first time the memory is reserved, and then it is quickly filled with the address for this string, bar. Then the constructor starts, which assigns name from the constructor argument, and then comes in our object initializer, which overrides it a last time. So what you have to imagine is that there's another line in here, theoretically, above this, which changes from null to bar. And then we change it from bar to foo, and then from foo to name. 3 different layers of assigning a value to our field. The direct assignment in the class up here, the second assignment in the constructor, and lastly, the object initializer. Well, I guess we can make it a fourth layer by just assigning the value directly in here. But yeah, that's how you can set fields and properties, depending on how you look at it, in C#. Let's switch our topic to another feature, optional arguments. Let's just keep the player as is. Ignore this part and move further down. Or, you know what? Let's skip all of this. Let's ignore player for now. No, I started with a player, so let's keep him in here. Just switch this up again. Go to this one. And actually, optional arguments, we can use the constructor already. See, p equals new player. 1, 2. Well, if I have a fresh player, they might just start out with 0 gold and 0 experience. Or maybe I want to start them out with some gold, but not with experience. It's a fresh character. Always writing a 0 in here, because I'm creating a fresh character, is a bit unnecessary, right? So we can just copy this. Actually, we don't copy this. We make an overload. We use a feature I taught you last time. We'll make an overload of the constructor that only takes 2 arguments, and then call this with name, gold, and 0. Use the this keyword to refer to our own constructor, and specifically the one that takes 3 arguments, and we call that from the constructor that takes 2 arguments. So I can leave this out. Again, this is nothing new. We talked about this before. Our constructor here is the one here, and this constructor method calls this other constructor method. This one down here, and that one will actually assign all the values. So this will still work. There's a different way to handle this though. It's a feature which is applicable to not only constructors but methods in general. Constructor is just a very special method, but this feature can be used everywhere, and what we do is we assign a value up here already. So far we've only used the space to declare variables, but we can also initialize them, kind of. I can use this, set this to 0, and I'm still using this constructor with only 2 arguments. When I call, it will still work. And what's happening here is that the computer knows I'm only providing 2 arguments. It also knows that the last argument has a value assigned already. So even though I'm not providing it a value, it knows it has a correct initialized value for XP. So it doesn't complain and just execute the code with the 2 arguments I've provided with the 2 values, name and 10. And this one just uses the default value in here. And this can also be something else. You can also assign the value of 1. Still just works just fine. And if I actually want to give a value, like 1000, I can do so as well. What happens now is that it will still provide the values for these 2 as before, and then it will override the default value for XP with the value I've provided, 1000. So I add the value in here, and it will trickle down as if this didn't exist. But if I don't add the value, it has now a default it can use instead. So I don't have to explicitly write that out. Important to note, in the background the computer still thinks of this as a constructor or as a method with 3 arguments. When I call player, the constructor is still the one with 3 arguments. You just hide it in the plain code that the programmer sees. We've hidden it, the computer sees the 3rd argument though. Important. This can have implications for backwards compatibility when you work with indirect access to libraries. Different topic that we might never even discuss, but just keep an eye on that. The signature for this constructor is still 3 arguments, even though we are hiding one of them from the programmer. Well, that's optional arguments. Although, actually, let's discuss a certain point here. These arguments can only be filled with constant values that are known, fully known, by the time we compile. So right now there wasn't any issue because this is just an integer value. No problem. I could also make some calculations, like I'm doing some variables here, and the compiler will just calculate the value and the result is 2, and it will just use a 2 then. So you don't have to write out the value, you can still use some basic math here. But I could not make any references to other classes. I could not use any variables. I cannot use a method in here, because this has to be known at compile time, what this exact value will be. Alright, so keep in mind, this has to be a fixed value that is known during compile time, a constant value. Just wanted to get that out there. And talking about constant values, we haven't talked about const so far, which is a pretty useful concept. So for example, public string default name, like so. Actually, public static string. Now we have player.default name, which is just a static value. Player.default name. And whenever I use this, it will refer to this string that is stored once in the program for the entire class player. It's a static value. And I could use this instead of this, for example. And if I don't want anyone to overwrite this value, I can use this keyword called read-only. I don't think we've talked about that before. Read-only means exactly that. It's read-only. It marks this field, default name, as being read-only. You cannot overwrite this. If I were to try to set, since it's a static, let's do it here. So player.default name equals none. Cancel. If this is not a read-only, and I compile, I will get an error because okay, I changed the default. That's another error. But if I assign this value, I'm overwriting the static value that's stored for the entire class player. If I change this to a read-only, I can't do that anymore. The compiler ensures that no one will overwrite our value. But the important thing is, this is still a field during the runtime. This part here is a constant. The compiler knows this value. It has to put that somewhere in the memory. It has to actually store that with the program. But this is still just a static field in the class player that exists during runtime, but not before. It's still a reference to some part of the heap when we start the program. It will be put on the heap somewhere. And there's an address that we store in default name, but that's it. It's an address to some spot on the heap during runtime. And once it is assigned there, we cannot change it anymore. That's it. That means we would not be able to put that in here. But actually we wouldn't be able to put that in here anyway. Right, I forgot to mention that earlier. these optional values can never be put in front of normal arguments. So as long as gold is just a normal argument that needs a value from the outside, I would not be able to put this in here. I can't use this as a default or as an optional argument. I can move gold in front just as the first address, or I can assign it a default value as well. And now this will work. Well, sort of. Because, as mentioned earlier, it has to be a constant value, one that's known at compile time. But default name is an address to the heap at runtime. So this value is not known when the compiler creates the program, because it refers to an address on the target computer when the program is running. The compiler cannot know this. The compiler does know this part, and we can change this whole thing from static read-only to const or constant. It will behave in a similar way to static read-only, but this time the compiler knows what this is. Whenever we refer to default name now, the compiler knows, oh, you're talking about this string that I've put in the program, that I know for sure exists and that I know where it exists and all that, because I've taken care of that myself. So now I can compile this program and this runs just fine because default name is now a constant. Big difference. It behaves almost exactly the same. At runtime, it doesn't really make much difference if it's a static read-only or a const. But for certain language features, it makes all the difference. But I can still just use player default name, just like before. And another thing, const is not only limited to fields. You can also say void something. Just some code. Actually, let's not put it in here. Let's just have a constant in here. I can use the const keyword just inside a method in regular code. And count equals 10. So, and numbers equals new int count. And bool flags equals new bool count. This is another popular use case. You have a certain number that you use several times in your code, and it has to be always the exact same value. If I use a variable, this count could be changed in between. And these two arrays would suddenly have different amounts of items in them. But if I do const like so, I would not be allowed to do that anymore. Complaints about the increment here. Compiler ensures I cannot change this value anymore. And so this way, I can be sure that this variable count will always have the exact same value when I use it. And this way I can just change my mind later on, maybe I want 20, and I can be sure that all the arrays will use 20 now. So that's a common use case. Just a constant for something in your program that is more convenient to change than writing it out by hand wherever you need it. Which also leaves you open for a programmer just accidentally writing in something else if there's a lot of rubbish in between. If we write out count, it's pretty clear what's going on, right? You know, it refers to a variable or a constant. Depending on your editor settings, you might actually visually see this thing is distinct from a variable, but that's syntax highlighting, that's for when we start with IDEs. So that is const. And while we look at arrays, let's say we have a method in here, public void shout, and this method will get string name Right line. Like so. Get p dot shout. Ooh. Like that. And our player will shout foo. Okay. What if I want to shout several names though? Well, let's write a different method. String name1, string name2, name1, and name2. You do it like this. No, that was one too many. Now I'm shouting out 2 names. And what if I want to have 3? Well, okay. Let's do one more. 3. Three. So, foo bar. And there we have 3. But adding a 4th one is getting kind of out of hand. Like, we have several methods already that all basically do the same, but every time I want to add one more, I have to write a completely new method. I mean, it's easy to use, I just have to add more names in here and will work just fine. So it's comfortable use, but hard to maintain and write. Plus, every time I have to change something, maybe I want to change like this. I have to write that out in every single of these methods. And I will always have a strict limit of how many names I can shout out. That's not ideal. So for cases like this, there's another special feature for methods. It's similar to optional values, but these are more, there's a value which you don't have to explicitly give. And the case we're looking at now is you can give as many as you want. And there's a special keyword that's involved, and that's params. What params does is it says the argument that's following it, the next argument, is going to be an array of something. So, for example, an array of strings. And it's going to contain maybe not a single name, or 1 name, or 2 names, or 100 names. Any number of names. It's a proper array. And it's filled with the values I put in here. So I can call it like this. It will have not a single value, it will be an empty array. Call it like this. The array will be exactly 1 element. Foo. Whoop, that was too much. And if I do this, it's gonna be 2 values, foo and bar. And now I can equals 0 is then it's just a normal array, so I can use this syntax. It's I. So let's, okay, I'm not gonna stitch this string to, actually, yeah, let's do that. Not the best way to do this, but just for completion for today. No 2. And let's do brackets. I equals length. Oh. It's 1. So we have a special case here where actually, if I do it this way, I have to arrange that as well. Okay, no, that's fine. No, that's fine. That's fine. We do it like this. Not equal times. There we go. shout and then shout name I, like so. And then we still have the other case of if it's any previous ones, we have to add a comma, but only if it's not the first one. So we do an else if. Again, this is not the elegant way to do it, but it works. I greater 0. Let's just copy this part. Let's quickly get rid of the but, like though. That's better. And with that, we should be able to run this code. Oh, right. Forgot to output. Right line and shout. So, doing it like this. Oh, that's another issue. Okay, let's do it like this. If I might just be dumb. Okay. So, foo and bar. Foo bar blob. And so on. So now this code can accept as many variables as we want, including empty ones. And in our case, it can actually accept null as well, which doesn't do much, but that works. And that's how we can pass on as many values as we want. We can also combine this with normal variables. So string meeting, like so. Can do it like this. The first argument has to be filled in. Oh, right. Wrong position. Sorry, like that. And better. Hello. Or we can do it high. Thing is, we have to include it. The first value is a string that we require. So this is a normal argument. We have to add it. But the rest can be left empty, because the rest is just params. Also interesting, we can just provide an array and pass that in. We don't have to pass on a list of names. We don't have to pass on a list of strings. We can give the entire string array. That's fine. We can't provide two strings, though. Two arrays. Can't do... This will not work. There's no method that can accept it. Except, of course, when I change this to having two square brackets. Or two sets of square brackets, because now this is an array of arrays. That would work again. Of course, no, my program doesn't work, but you get the idea. Let's correct that. Actually, let's switch that back to here. Now let's change it to here. Like so. Next feature. This constellation of having a for loop, which just iterates through an array, for example. There are other data structures like that, but for now we only know the array, so let's keep that in mind. All we do in here is start with an index of 0, and then in each iteration of the loop, increase the index by 1 to get the next value in our array. I mean, specifically in this case, I'm also evaluating the I, the iterator, for some other properties, but let's say I am just outputting the data as is. Without anything else. Also, let's drop the greeting. Right, like so. We don't really need the I anymore. We only use it as a means to get through the array. And for cases like this, there's an easier structure, which is the foreach loop, which is basically an optimized version of exactly this constellation. Foreach is built with the idea that you can create this and then have string. Let's change this to names, plural, so it makes more sense. String name equals I. And then down here we can just output name. Let's cut that out quickly, just test it. So this code still works. Foreach is an optimized version of this, where we only need to provide the data type and the name for the variable we want to look at, each item we look into at each loop, and of course the name of the variable we want to iterate through, or the list, the array structure. And we start off with the name and type of the variable we use in each loop to access one of the items. And then we use a colon and provide the name of the source of all the values, so names. Like this. Oh, sorry. I'm sorry, wrong language. Slipped up. Okay, that was bad. In C#, it's in, not a colon. Why did I get that in my head? Why now? I haven't touched that in so long. Why did I think colon now? Okay. The downsides of learning multiple languages is you sometimes mix up the different language styles. Yeah, whatever. So keyword for each, keyword in. This is one-to-one, this part up here. And this is one-to-one, this part here. All we do is iterate through the entire array names. And for each item in there, we're gonna copy the value into the variable name, and then we can use it. So one thing to look out for, name is read-only. So if I try to do this, can't do that. I could do that in here, because that variable is mine. I have absolute control over it. That's fine. I mean, not a good idea, but that's fine. For the for each loop, the variable is locked. We can't change it anymore. But talking about loops, let's have another idea. Sometimes you want to control how often the loop goes through without relying on a condition in the head of the loop, or the foot if we have a do while. And I've used that before, but I have not explained it. We have seen the keyword for this before. If I greater than 2, break. The break keyword. You saw that first in the switch statement, which was required in there to tell us that a certain case has ended and we are going to the next case for the switch. You can also use that for loops, which I've used before, but I've, again, not explained it back then. If you use break in a loop, it will simply say stop the iteration of the current loop and then stop the loop altogether. So right now, it will output all 3, but if I add 4th one, we won't see it. Because when the I is greater than 2, it will simply abort the entire loop and we end. So only indexes 0, 1, and 2 get to output the name, and index 2 will simply stop the entire loop. If I go to 1, or maybe just equals 1, then we'll output only high. Because as soon as we hit the second index, index 1, we'll end the entire loop. There's another keyword though, that's also specific for loops, and that one is called continue. That's a keyword, and just like the break, it will abort the current loop, but it will not abort the entire loop altogether. What this does is simply return to the top as if we executed the entire loop body and continue with the next iteration. So a break will abort the entire loop structure, everything, but the continue will just skip the current iteration. What that means is we get high and bar, we don't get the foo. So if it's 2, 2, we get the foo but not the bar. And sometimes this is very convenient when you write your loops just to make some simple optimization. Either make it easier for the computer to process or make it easier for a programmer to understand. Because certain conditions, you know, you can just skip ahead, or maybe you know you don't need the loop anymore altogether. There's a lot of juggling you can do with your code and the logic behind it once you have these 2 options, continue and break. Oh, by the way, specifically for the for loop, should maybe show you something. And I equals 0. So we can just put the declaration to the outside, like so. Actually, let's put the... That looks a bit more natural. Right line. I is... that as 4, because our array has 4 entries, so index 0, 1, 2, and 3. And once I is incremented to 4, and we check this condition again, it will not be less than 4, it will be index 4 equal to 4, which means we abort the loop. And so the last value of I is 4. Makes sense. If we break, however, we stay at 2. The point where we broke off. Let me show you a difference here. If I don't do it like this. Let's put it like this. We continue as long as I is not 2. Let's just comment this out. And now put that back in. Actually, let's just return it. Point is, if this condition is applied, if I breaks at 2, it will not attempt the increment again, it will not attempt the condition again. So if you break at index 2, it will stay at index 2. Whereas if I just let it run out, it will break on this condition, which means the index will be actually the index for the iteration after the last iteration. That makes sense. That's sometimes important. If I want to know, for example, if the loop prematurely was exited with a break, I can just check the I. If I is equal to 4, I know it had to run this code up here, which means it dropped because of this condition. If I is less than 4, it must mean that this was not the reason the loop ended. It has to be a break in between. Just a side note. Sometimes that's a quick and easy way to store the information that you prematurely ended the loop without having to add another flag. Just check the variable that iterated through. Anyway, let's have a talk about naming conventions again. Let's drop this one. What happens if I want to name my name lowercase, like so? I have now an argument name. This is a variable limited to the scope of this constructor. Only exists in here. But I also have a field called name, which is scoped to the entire class, which exists here and outside and everywhere. So now I have the same name from different sources. What happens? What will happen when I press run? It compiled. Okay, but what did it output? Let's actually put some value in here. Let's just output the value p dot name. What will it be? Oops. Okay. Now, what will it be? It's a null. Now give it a quick thought. Why is it null? The reason is we have name from the scope from our class and name from the scope of our method, our constructor here. And no matter which it chooses, it's only going to assign to itself. It's not going to mix one with the other. Because maybe you mean that this is the class scoped field name and this is the argument which only exists in the method. Or maybe this is the argument and this is the field. It can't make that decision for you. You could argue that it should just count this as an error because you're mixing two different scopes and you have the same value, but there are other limitations then. It happens also in just general. If I have another int xp in here, if it wasn't an argument in the method, in the constructor, and if it's just a normal variable I create inside a method or in the constructor itself, if it clashes with the name of something else here, I can do that. It's just we're changing the meaning of these variables now. We're having these conflicts. And to resolve this, we use a keyword that you've also seen today and we've learned about before. It's this. Remember last time we talked about base, and I told you that when you say base dot, it means to refer to a value or a method of your parent class, of the base class. If you just use a field or a method, you refer to yourself. If you say base.method, you refer to the method as it's written inside your base class. And this works just the same. If you say this dot something, you refer to yourself, which you can do basically always. It's just usually you don't, because it's pretty clear you're talking about yourself. This is a scenario where it's useful to do so. If I say this dot name equals name, the computer knows exactly this refers to my instance, to the class dot name. It's the same as writing p dot name here. And we assign that the value of name, the variable that's local here. We solve the conflict. Computer knows exactly this is the local scoped name, this is the globally scoped, or somewhat globally scoped field name. I can do that here as well. There's no conflict, but doesn't matter. Computer still knows what I mean. It's just redundant. That's why you usually leave that out. But you can add that to resolve conflicts like this. So maybe it's more of this case. We have the arguments uppercase as well. Same scenario though. But that's another reason why different naming conventions for different places. Then you don't have that confusion at all. Let's talk about another feature. Earlier I had this weird string setup where I had to make a lot of strings and add something, add the variable and more strings and adding more stuff, which was a bit long-winded and yeah, a bit too much. There's an easier way to handle this kind of stuff, though I admit I'm not sure if this online compiler has all the features. I thought it was 7.3, but it's not, so... But that should be in 7 already. And it's called string interpolation. Basically, when I write this, I'm concatenating this string with the string that's stored in name. Right? But I can also simplify this. To do so, I first have to add a $sign in front of my string. By doing so, I mark this as an interpolated string. It means it's a dynamic string, so to speak. The compiler knows I have to treat this not as a normal string. I have to actually do some processing first. And inside the string, I can now use curly brackets. And inside these curly brackets, I write code. So if I do this, I'm still getting name is foo. If I don't add the $sign, the computer will just think of this as a normal string and output that. But because I added the $sign, it knows this is an interpolated string. The curly brackets have special meaning. What I put in these curly brackets has to be processed, it's code. And basically what the computer will do in a case like this is convert this into just... At least if it's properly set up and optimizes correctly, it will just change this to add. Just concatenate these two strings. But I can do that... What just happened? Okay. Is named so-and-so. Let's add... Yeah, let's add these for now. So, now we can use the curly brackets again. p.gold and p.xp xp. I can run this, and I get a nicely formatted string with everything I need. It's just a way more convenient way to write this out. And again, this is basically just code what we can put in here. And that means I can actually write out code like the so before, but I have to add brackets now. We have to tell the computer that it has to first evaluate the entire expression within these normal brackets, and the result is what it puts inside these curly brackets. Because while it is code that is executing, there are some rules to it that give it some special properties. We will need to talk about those when we talk about string formatting again at some point. Which we'll get to. If you thought of string format, we'll get to that at some point. Yeah, if it's null, then... Now this will look a bit weird, because the syntax highlighting for this editor doesn't quite get interpolated string. The compiler knows how that works, but the syntax highlighting here doesn't, so it assumes our string ends, because I have these quotation marks. But these quotation marks have nothing to do with these quotation marks on the two ends. Don't get confused by the coloring right now. And otherwise, yeah, let's just do it like before, plus... So... dot name. Can do it like that. So that's one way to do it. Or we can of course use interpolated string in here as well, inside the part that is also part of the larger interpolated string. And we just have this removed and use curly brackets in here too. Like that. It's a bit of a weird construct, but it's valid. I try null. Get a null. So, interpolated strings. Quite useful if you want to write out some special text, especially for debugging. Just quickly writing it down and adding a couple of variables in there. Very convenient. And one last topic for today. Public void get stats. Let's say I want a method that just quickly gives me the rundown of all the important stats about a player, which right now would be only the gold and the experience they have. Let's say that. If I use a single return value, well, I can only use one integer. It can only return the gold or the experience. And the workaround for us was to just have out variables and then write the stuff in here and xp like that. And now I can just call get status and get the two variables out and gold, out and xp. So that's one way to do it. Alternatively, I could of course create my own data structure, like a struct, that's only for the relevant stats. So I could just make a public struct. Yeah, stats. It's unnecessary, but couldn't do something like this. Public gold, public and xp, and then turn new player stats, the default constructor, and we make our life easier by just using the object initializer that we've learned about. Gold, XP, what's XP, something like this, right? Or we could use a constructor and be done with that. And then we would return the player stats here, of course. If you have several such methods, that would get tiresome. You have to suddenly manage several different types, and the alternative would be to suddenly have to manage a lot of out variables whenever you call the method, which is not the point. I mean, there's a reason I'm not calling p.gold, p.xp on its own. I want to avoid working with the variables directly. I just want to get quick stat overview that I can pass on to somewhere else. And for cases like this, there is a type already delivered in C#. Or actually there are two types that let you just quickly put together a couple of variables in a structured way. So not as here's an array with different values, but actually similar to a struct like we had before, or class. A thing where we have properties or fields with individual values that you can access. And these types are called tuple and ValueTuple. And tuple is a bit specific. I don't like tuple. I'm forced to work with it sometimes, but it's not very nice to work with. Personally, I don't like it. ValueTuple, on the other hand, love them. Use them all the time, and they get some special syntax. So today we're only looking at ValueTuples, because honestly, tuples can go die for all care. So what we do is define a return value, and we're not saying this is a value tuple. No. We have special syntax for this. We use normal brackets, and in here we define the values that are stored in this tuple. So we might have int gold and int xp. So similar to writing out a struct, which is just a field gold and a field xp, we just have these normal brackets with gold and xp. And when we create the value, we also don't use new value tuple, which we could in theory. And just to throw that out there, value tuples can be used like a normal type or struct, but we're not going to do that. Partially because we have to do generics first, and they're larger topic we're going to talk about next time, I think. I'm not too sure. I have to look at the timeline. I think it was next time, generics. Anyway, what we do here is also special syntax. We use normal brackets again, and just write out gold and XP. We use the variables directly as they are used in here. You could also put in constant values here. That's just fine. That's it. That's get status. And on the other hand, what we get here is value tuple with gold and XP. This is still like a data type. It's just that the name, think of it like the name of the data type is the description of the entire interior. Think of it a bit like that. And it behaves less like an object or an instance of something and gets some special syntax to create it. So it's more like just returning a value. So special syntax, which makes it super easy to use and also super easy to abuse. Just a heads up, I can add more variables in here, but there's a limit. I think 7 or 8 maybe. And that's where it stops. Everything more, and you have to use different methods of returning the values. But also, once you have a value tuple with maybe 7 different values, I think a dedicated struct might be worth it, because I'm questioning what you're programming right now. If you need a value tuple with 10 values. Right, that's how I use it. The question is, does this language version already know ValueTuple? get status, gets... Oh, get stats. Okay, it does know it. So I can do this. Let's do string interpolation again. Gold is stats.gold and XP is stats.xp. You might be using the names as they are defined in here. Also note, I can't put anything in here. I could put an uppercase G and that would still work. In fact, I could even just drop this part and only say I'm caring about the integer, just the data types. That would work as well. So it's a bit strange in that sense. I'm using names in here. Wait, where is it? Okay. Okay, more syntax. Ah, weird. Anyway, I'm caring about the values. Why is it not switching? Is my code gone? What is going on? That's better. Okay, some weirdness with the undo buttons. Let's not touch that undo again. Anyway, what I care about is having the names in here because it makes it easier for a programmer to see what the return values are supposed to be. That's the only reason I have them in here. If a programmer writes in here, they know, okay, this is what I'm expected to return. And if I'm using this code as a programmer, I know, okay, I'm expecting gold and XP to come back to me. I'm already caring about the names in here because, well, I have to actually use these values. Right, but these names are entirely different from these names. And in the method itself, we could even skip the names altogether. That would be fine. And we can actually go a step further. Just as how we can use special syntax down here to just skip the whole new keyword, we can also skip this part up here to just not have a value that we have to use as an indirect access to this stuff. We can just do it like this. And it's like having two return values that are assigned to two different variables in our code with one instruction. So that still works. Very convenient. So this is something I've hinted at in an earlier lesson. There's another way to get multiple values back. Very convenient way with ValueTuples. There are other things you can do as well. For example, if I use them in code, I can use, let's make it int a equals 10 and b equals 5, so a equals b. Let's do it like that. Maybe I want that. So a is 10, b is 5, and I can use ValueTuples as a way to flip these two. AB is equal to BA. Because this syntax for creating a ValueTuple, I can use it everywhere. I can just write this out and I'm creating a ValueTuple here. And I'm assigning it to this other ValueTuple. And they don't care about the names. We can leave out the names in special circumstances. So if I'm already declaring the variables a and b, I don't need to name them in here or declare them again. I can just run this code. And this way I can swap the values. There are other ways we can swap integers, by the way. This is not necessarily the most performant one, but it's very easy to understand. And if we return the code a bit, just to demonstrate. Right now I'm using int gold and XP in here. I'm declaring both up here, but I can also just declare them beforehand, use them for something else, and then have the system just override them. This is possible. I can do that. If I don't set this, get the original values ahead. But with this, I'm using the special syntax for value tuples to have them just filled with 2 integers in order that I get from getStats, which are these 2 integers in that order I got from this class. So value tuples, it's a bit weird, they break a couple of rules we've learned, but they are super useful. And I feel like it's best not think too hard about why value tuples work and how, and just accept that they exist and be grateful for this glorious gift. Not like normal tuples, which still... I don't like them. I really don't like them. I sometimes have to use them because we still have code. We have at least one code base that's locked to C#5, which cannot be upgraded. And I'm so looking forward to the day when I can finally put an end to that repository and archive it for good. Never have to see it again. Dang it. Anyway, yeah. That's value tuples. And with that, we've covered all the topics I wanted to discuss today. So we had object initialization, we have optional arguments, we have the const keyword, how to create constants, we have the params keyword, how we can provide any number of variables as long as it's the same type to a method. We have the foreach loop, which is a special variation of the for loop, just a bit more comfortable to work with in some cases. We have the break and continue keywords, where the break you already know, but it has a different meaning in context of loops, and the continue keyword, which is special to loops. We have another use for the this keyword, why it exists and where you might want to use it, besides referring to your own constructor, which we did in the very beginning. We discussed string interpolation, which is another way to just format your strings, so to speak. And we discussed the value tuple. And your homework will just be to play around with all these features. Try to implement at least one example for each of the features I discussed today, and maybe get a bit creative. Experiment with your code a bit. And look forward to the next time when we do indeed talk about generics. Alright. Until then, bye.